So on your screen here, you see a bunch of different weird looking shapes. In the left side, you see shapes that we're going to call widgets. In the middle, you see shapes that are not widgets. So your task is two different things. First of all, decide which of these four, A, B, C, or D, A, B, C, or D, are widgets. And once you have that, see if you can write down what a widget is. I'll wait for you. All right, so did you figure out that when you're looking at these things that A is a widget and the others are not? So then what is a widget? Well, maybe a widget is a, let's see, it looks like the four that are widgets here on the left, these four all are colored shapes. So it definitely is a colored shape. But if you notice some special things about it, it's a colored shape, but the reason why this one is not is it has two claws. And this one has three things, and this one's got stuff on the inside of it. And this one has like an eyeball maybe and a claw, but there's no color on the inside. So it's got to be a colored shape that maybe we'll say has one claw and one eye. So that's how we'll define a widget. Now, please understand something. We're not going to talk about widgets this year, but what the process you did was writing a good definition. You looked at what widgets had in common and then what differentiated it from others. And that's the important thing for today. Here's another example. Everybody knows a square is a figure with four equal sides, but that's not right. So can you sketch a counter example? Meaning, can you draw me a shape that has four equal sides, but is not a square? And extra bonus points if you can find more than one. Give it a shot. So many times in class, I'll see students that draw things like this. And I'll say, well, that's not really, it doesn't really have four equal sides. But when they do this, I say, oh, you're right, it has four equal sides. But maybe that's not a square. Maybe even a better diagram of it would be something like this. I have students who draw that. That's a much better example because it's a figure with four equal sides, but it's not a square. Maybe another one would be this. That's a figure with four equal sides, but it's not a square. So can you write a better definition of a square? So maybe we say something that is square. Oops, let's spell the word square correctly. A square is a four-sided figure. Okay, that eliminates this one that I drew, the crazy one on the right, with four equal sides. And to fix this figure that I drew on the left, let's also say it has four equal angles. Because now if I take that definition, I have to draw a four-sided figure. And all four sides are equal, but also four angles are equal. I can really only draw this shape in red. So that's a much better definition of a square. Let's do the same with these two definitions. We want to first define parallel lines. And if you look to the right here, line I, here's line I, and line J are parallel. Please notice, this symbol in the middle here is the symbol that we use for parallel. And likewise, these two lines down at the bottom, lines K and L, are perpendicular. Where'd the K go? There's the K. Oh no. There's the K. And please notice the symbol here, the upside down T, means perpendicular. So we first want to define parallel lines and perpendicular lines next. Give it a shot. Okay, so a lot of students will say things like parallel lines are two lines that never meet. And I'm going to kind of draw you two lines that never meet. Have you ever seen a box before? Well, think of the line that contains this side of the box here. And then think of the line that contains this side of the box here. Those two lines will never cross each other. I know that in my drawing that it eventually will cross like that. But if you think about this in three-dimensional space, those lines will never cross. But they're not parallel. So what we want to draw, what we want to say instead is we'll say two lines in the same plane. Remember that word plane from a couple days ago. And we'll say that they do not intersect. They never cross. That's a much better definition because now the lines are in the same plane and they don't cross each other. So now going down to perpendicular lines, notice that these perpendicular lines, they have to cross each other. So they have to be in the same plane. So we don't necessarily need that restriction. But look at the angle that's formed. Can you tell that that little box in the corner means it's a 90-degree angle? So let's say that perpendicular lines are two lines that intersect to form a 90-degree angle. That would be a good definition of perpendicular lines. Two lines that intersect and form a 90-degree angle. I can't break that definition. Meaning, if I draw two lines, here's one, the second one has to intersect and form a 90-degree angle. Well, it can't be that one, because that's not a 90-degree angle. So it has to be, let's do a little undo, it has to go that way. Those lines have to be perpendicular. So what I'd like you to do now is if you're in my classroom, there's a link on Google Classroom to an activity on a website called Desmos titled Classifying and Defining Angles. What you'll do is you'll see pictures of angles, you'll be told what they are, and also what they're not. Write a definition. When you do, you'll see some of your classmates pop up as well. Read theirs and improve yours until we can get a good class definition. Hey, welcome back. So let's see some of those definitions. You might notice that a right angle is an angle whose measure is 90 degrees. We kind of talked about that with perpendicular. An acute angle is an angle whose measure is less than 90. Obtuse is when the angle's measure is greater than 90, but less than 180. It's between 90 and 180. Complementary angles are two angles whose measures sum to 90 degrees. So maybe I'll draw a picture for that one. For complementary angles, let's get a little bit of room. Complementary angles, maybe those two angles are complementary. So I'll say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Three other definitions, just like the complementary, we have supplementary angles, two angles whose measure sum to 180. So in this case, the measure of angle 1 plus the measure of angle 2 equals 180. The next two kind of go together, a linear pair of angles and vertical angles. A nice diagram for both of these is if we draw two intersecting lines. And I'm going to number these angles 1 and 2 and 3 and 4. So linear pairs of angles are adjacent and supplementary. For example, like angle 1 and angle 2. They form a linear pair because they're adjacent and supplementary. The same can be said for angle 2 and angle 3. And also angle 3 and angle 4. And also angle 4 and angle 1. The vertical angles, though, are the non-adjacent angles. Those are the angles that are not next to each other. So vertical angles are like angles 1 and 3, or angles 2 and 4. So these are definitions of angles and lines, like parallel and perpendicular, that you should be comfortable using.